It's time to begin today's webinar. Welcome to everybody attending and thanks for your participation. My name is Anders Kjellow. I represent the Danish Technological Institute, who are coordinating the Build in Wood project. The purpose of today's meeting is for us to be able to give you some insights into the activities that's been going on in the Build in Wood project so far. Let's see if I can bring up the agenda here. We have today the following program. We will first hear about, after this introduction, we'll hear about the early adopter cities and our work with them, presented by 𝗕𝗵𝗽. Then we'll hear about the Build in Wood building system, presented by the 𝗕𝗵𝗽𝗀 architects. Then we'll have a presentation about why timber is better than the building law thinks it is. An interesting title there, presented by my colleague 𝗕𝗂𝗏 from DTI. Then we'll have a presentation about post-occupancy evaluation of timber buildings, presented by Alexandra Institute and DTI. And then we'll have a presentation about LCA and BIM and why that is potentially a very efficient combination, presented by University of Siena and 𝗕𝗵𝗽𝗀. Before that, we'll just give you a very brief introduction to the Build in Wood project. We are a European Horizon 2020 project with a 4-year duration. We are about halfway through the project at this point. We have a total budget of about 10 million euros. We have 21 partners from 12 countries. Our overarching objective is to make wood a natural choice of building material for the construction of multi-story buildings. It is to decrease the greenhouse gas emissions of the European construction sector, and it is to establish an innovative and sustainable European value chain for multi-story wood buildings. We also want to improve the connection between rural and urban areas, and we want to contribute to sustainable urbanization and increase the productivity of the European construction sector. We have the societal challenge of urbanization and increasing population, and we have estimated an annual demand for new apartments in Europe alone of about 1.6 million per year in the time between 2020 to 2050. So we have a very large demand for building materials. And if you look at new construction, the emissions from material production are now higher than the expected emissions from the lifetime operation of new buildings. And so there is a need for us to focus on emissions from building materials and not only on operational energy emissions. There are, of course, many reasons to build with wood. I will not go through all of these, but just to mention a few here. From an environmental point of view, wood is a renewable material, which is the only one of the major building materials that's renewable. It gives us great opportunities for greenhouse gas reductions through both sink effects, because wood stores CO2 as it grows, and through substitution effects by not using more energy intensive materials. We also have a range of economic possibilities. When building with wood, it enables fast construction. It's a light material. You have possibilities of putting more stories on fragile terrain. You need less infrastructure on site. You have fewer transports because it's a light material. It's very well suited for prefabrication, which gives you a high productivity in the construction sector. And so all these things translate into economic opportunity. We also have social sustainability benefits when building with wood. The forestry sector and the wood sector in general provides green and decent job in your rural areas. It gives you, on the working side, an enhanced working environment with less dust and less noise. In the working environment, wood can be worked with using small handheld powered tools. You have less disturbance of neighbors during construction because it's relatively silent construction. And so there are a range of social sustainability benefits also to building with wood. There are, of course, a number of barriers that are hindering the large-scale market uptake of wood in the construction sector. We have identified some of these to being lack of industry know-how and experience, lack of optimized and standardized materials, regulatory barriers such as non-harmonized legislation, lack of open source information, lack of legislative focus on carbon footprint of building materials, and building materials often not being included in carbon accounting. Then there are some safety and performance concerns, mainly related to fire and acoustics concerns. And then there are also these concerns about do we have enough trees, and wasn't it better to leave the trees in the forests? And so what we try and build in wood is to address all these barriers. We focus on the area where we expect the highest demand, which is multi-story buildings in the lower level. You can say we're not in this to break world records in terms of height, but more in the high demand market. Then we try to break down the value chain into manageable parts and to address the barriers within each part of the value chain. And this way we hope to reduce the perceived risk from stakeholders who want to build with wood. Some of the selected activities that is going on in this project here are included here. We do a development of an adaptable and cost-effective wood building system for multi-story wood buildings. We do a full documentation of that building system. That's both from a technical, environmental, and economic point of view. We do analysis of member state building regulations. We do a post-occupancy evaluation of existing buildings. We do a fully developed BIM library for the building system. We establish an international community for wood construction, and we work directly with cities and are arranging more than 20 targeted workshops in each of these 7 early adopter cities. And so the list goes on here. These are just selected activities, but some of these activities we'll hear about today. And we will start with hearing about the early adopter cities and some common challenges and opportunities presented by Sabina Glioppa from 𝗕𝗵𝗽. So with that, thank you from my side, and yeah, over to you, Sabina.
Thank you, Anders. Here we are. So my name is Sabina Glioppa. I'm an urban planner. I specialize in regional planning, and I'm here on behalf of 𝗕𝗵𝗽. We are team leaders of the involvement of external early adopter cities, as we call them. During this webinar, we want to tell you a little bit about why we involve cities in this project and why we think that cities and metropolitan regions are very important to include in the discussion about supporting multi-story wood buildings, and why their unique role at the articulation between European policy and on-the-ground innovation is key to getting the agenda going. So what we do here in the project is to involve the early adopter cities, EACs as we call them, in developing strategies together to support the reduction of greenhouse gas emissions via the use of multi-story wood buildings and via the use of support mechanisms for the multi-story wood buildings. They have 3 roles in our project. The first one is to let us know their needs, their requirements, to provide us with data that the project can use, and this part in particular will be covered by the next presentations of my colleagues. The second one is to define and co-create together with a community of practice, as we call it, a growth coalition at local level, so external stakeholders, which can be building companies, architects, engineers, universities, providers of training, sustainable strategies and pathways in order to support multi-story wood building in their cities and metropolitan regions. And the third one is that we really want to promote this concept of being an ambassador of building with wood, because we do feel that there is not enough policy support and there is not enough example of best practice currently in what concerns pathways to lower the embodied carbon in the building environment and to be more sustainable in a holistic manner. We think that this is a very good time to involve the cities because what happens is that if all construction activity, including renovation, is taken into account in the analysis that's being conducted at the UN until 2060, the construction activity carbon is set to exceed 230 gigatons. So the emissions gap report from 2020 from UN, the UN Environmental Program actually identified the fact that a green pandemic recovery could cut 25% of the predicted 2030 GHG emissions. So now we feel that with the, at least in Europe, with the Recovery and Resilience Facility, putting 37% of the funding in recovery in actually a green transition, that this is a very good point in time to prioritize the adoption of policies supporting low carbon materials across Europe. What we think about cities is that they have this key opportunity to be facilitators, so to coordinate the shift to a greener development, to coordinate a partnership and to coordinate local dialogue, but they're also enablers because this is the interesting part that we try to tackle in the project. They have policy levers that can enable wood either implicitly or explicitly. They can develop regulations, they can actually change procurement to not be dismissive of wood, and they have the possibility to develop facilities and financing. And last but not least, we see them as role models, and we see them as inspiration for other cities as well. And what we try to do in the next steps is to promote them as best practices. We also have challenges because there is a lack of experience and there is a lack of technical expertise. There's always some preconceptions about wood that are obviously not well founded, but not many people know that except the people that are actually engaged in building tall with wood. And there is a very big connection between the urban and the rural areas, especially now when we talk about disrupted value chains due to the pandemic that is lost. And there's a low value chain integration that we feel that needs to be addressed with this communication. Two things are very important for us. Currently, we do have methodologies for sustainable energy action plans, for sustainable mobility plans, but there is a policy support void in what concerns addressing the decarbonization pathway, factoring in embodied carbon. And there's also practice knowledge voids because we feel that there's little structured learning, and we try to address that with the project. So we started from these general challenges, and within Work Package 7, what we did was to start involving these early adopter cities, which I'm going to present one by one, to create local communities of practice, to address their ambitions that are either strategic, like net zero strategies, or operational, like new regulations for the built environment, and to support their local dialogue in order to create or to reach these pathways. Last but not least, there is the possibility to have the real life scenarios and real life cases for the built-in wood project, for the design guide and design manual, something that you will learn from my colleagues in the next presentations. So just as a helicopter perspective of what we're doing, we have an iterative process. We have established a link, a cooperation with the early adopter cities, and they have set up local working groups, so key stakeholders from all the environments. We've prepared with a set of questionnaires to understand the needs of these cities, and we looked at their policies and the local context. And then we had a first workshop, which we're going to tell you all about. And we talked about challenges and opportunities that are personal and specific for that city. And then we looked at the common challenges. And in the next steps, we are going to have 2 more workshops, and we are going to have a European dissemination and networking period. In what concerns the first workshop, just a very brief introduction to it. The pandemic hit, and then we had this weird online and offline discussion series with all the cities. But all in all, I think that this first workshop actually offered up two very important conclusions. One of them is that while all cities have very specific needs like densifications or building up or building out of existing buildings or renovating or the necessity to supply more housing, all of them have the same legislative, regulatory, conception, training gaps, and all of these other challenges that could be addressed in a unitary manner. We started with the Brașov metropolitan area, which is the full project partner in Built-in Wood. And just to show you a little bit about the priorities that have been discussed so far, they're looking at pro-wood policies, such as tax rates or wood enabling policies, public buildings and procurement. They look to support ongoing legislative changes in Romania because there is an ongoing movement to redo the whole building code and planning code, and to, of course, integrate the local value chain. We are also happy to welcome Copenhagen, and we, for the last year and a half, we worked with Copenhagen on their priorities because they do have a very strategic-oriented approach to enabling wood in the built environment. They have some challenges regarding the legislation and building codes. And of course, each of these cities has gone through a workshop where they discussed what the gaps are and what the priorities would be. So now we can look at strategic pathways going forward. Haringey Borough is focusing on a retrofit first approach and is aiming at supporting a building in wood policy, either standalone or part of a larger embodied carbon policy, which ultimately could scale up at the whole city level. And of course, there is a lot of challenges that they want to address that are both, let's say, about conception, about strategy, but also about very operational questions such as ensuring interoperability and ensuring or encouraging the potential future reuse, incorporating the circularity principles in the built environment. Innsbruck is having some interesting challenges about a high density urban area that is constrained by natural elements. So for them, they want to actually support the shift to wood in this context, and they look at policies for timber construction support, they look at carbon accounting, and they look at perception change at local level, because wood cabin, the perception of wood destined for wood cabins is something that is, for example, shared with Brașov, but it's something that is stopping in the minds of the consumer an adoption, a larger scale adoption of wood. Trento, they're having the same high density urban area issue, and they're looking at the retrofitting needs that they have. Their priorities are a city sustainability strategy and embedding wood building in the green policy framework. They are Italy's greenest city, and it's very important at their level because of the natural surroundings to address this wood chain fragmentation and address missing links so that the urban-rural linkages for a local development, a local industrial development for this sector is supported. Trondheim are our wood building pioneer. They have a lot of experience in building in wood and creating wood supporting policies, and their priorities going forward are the focus on city sustainability as a whole, including and beyond wood, design for disassembly, material use included in building regulations, better communication, innovation and optimization for timber building systems, and they also want to look at the tender system. Last but not least, the newcomer that we're very proud to welcome is the Metropolitan Region of Amsterdam, and they will have their first workshop next week. They are having a general challenge that is shared with the other cities, but they also are a frontrunner in circular economy solutions. So their priorities would be on policy development, on standardization, on the integral assessment of sustainability on a systems level. What we did was cluster at the end all these common challenges and try to support a program that addresses each of the challenges based on its categories: ambitions, targets, visions, legislative and local policy, financing and tendering, LCA measuring and monitoring and communication and perception change. Our next steps right now are to focus on 2 points in the second local workshop. We will have a strategy and policy part that is connecting all these challenges to either implicit or explicit wood support policies and approaches. So for example, looking at building regulations, looking at carbon limits for public procurement, looking at how to adapt local regulations to be more wood positive. And on the other hand, the Built-in Wood project is quite advanced right now, so we will also address the possibility for the technical and scientific cooperation, so connecting local knowledge needs with our evidence-based research in Built-in Wood, which we'll share you a little bit about in the next presentations, and also to address specific programs such as renovation, densification with digital pilots and technical outputs. The outlook is for our final task in the project that we are preparing right now is the methodological transfer and support the replication support, and our ambition is to ensure the impact not at European level but at global level, and we're very happy to welcome in this webinar professionals from all over the globe. We want to widen the cooperation and support other stakeholders and cities with priority cities and metropolitan regions, and also regions to join the discussion and to join the community that we are going to launch, and also to have policy learning that would support European policymaking for multi-story wood buildings. You can join us at Built-in Wood. You have the links. This presentation will be shared with all the attendees, and we want to welcome you in our digital communities. And I'm going to stop here, and I'm going to thank you for your attention. And I'm going to pass the baton to the next presenter.
Hello, I'm 𝗕𝘂𝗶𝗿𝗁. Oops. I'm 𝗕𝘂𝗶𝗿𝗁. I'm from 𝗤𝗏𝗡𝗁 Architects, and we are leading on the development of the structural system. It's so great that so many of you are here today to join in this and have such an interest in building in wood. We've been a practice that has focused on sustainable architecture for the last 15 years. We've been building in engineered timber for that time and have become internationally known for our experience in timber construction. So we were delighted to become part of the Built-in Wood programme. So as we all know, and I think has been sort of expressed already, if we carry on as business as usual, we won't be hitting the targets that we so desperately need to hit. So the reason for Built-in Wood is to make timber construction methods common practice in the European construction sector, and making it easier for stakeholders to choose a healthy and sustainable alternative to traditional construction methods and systems. And so what we're doing is to kind of break down any barriers and it's a really fascinating project because it goes from testing small components to understanding what the policy constraints are for timber construction. And so I'm just going to talk briefly about the structural system, which our brief primarily was to design a multi-story building system, which was for between 4 and 10 stories, as we felt this was a sweet spot for the kind of development that European cities are looking to develop. And it should be adaptable for both commercial and residential. So we're thinking about, from the very outset, thinking about demountability and change of use throughout the process. And then it also has a facade panel which can be used on retrofit as well as on new build. We're looking at different climatic conditions across Europe, different regulatory requirements, which we've done an analysis of with our partners to understand what the range of different thermal, acoustic and fire requirements are for buildings across Europe. And we're also looking at retrofitting, which is a key part of becoming zero carbon, because we need to upgrade our very low quality building stock that we have at the moment. And so we need to optimize it, as I mentioned, for reuse and resource efficiency. So when we're thinking about the principles for the building wood system, as I mentioned, it's integrated, so it can be adapted to different uses. It needs to promote the use of timber. Adaptable, we need to be thinking about the criteria for each project. So the way that we've designed it is such that when you're thinking about using this system, you can plug in your different regulatory requirements. You can think, obviously plug in what your uses are, whether that's residential or commercial, and then you apply those individual requirements to a range to the system. And we have developed a range of different build-ups and details for the system to cover low, medium and high regulatory requirements. And then we've looked at different material solutions, and the system itself is going at the moment through testing and accreditation. And so the key aspects of the system that when we're thinking about using it is to define the dimensional range, define the materials that we want, define the beam orientation, so that when we're looking at it, we know that all the services are going to work in a sensible way. And then we have a specific design for the core, and we can also integrate other off-site manufactured elements such as wet areas for bathrooms. And then we've worked very hard with 𝗵𝗿𝗆 on all the connection details to make sure that we have a kind of suite of details that can be used quite generically across the system, and also doing some clearly doing analysis around durability, and also using our expertise to help others in detailing timber buildings. So the adaptability of the structure is key, and what we found is that if we took this small area of Hackney in London and applied the system to a range of buildings, and given that the system can be increased or decreased in size and can change in use, we discovered that we could accommodate, or we could rebuild this area of London. 70% of it could be rebuilt in the system, as you can see here. So as I mentioned, it ranges from 5 to 10 stories, and with that we have a range of bay and grid sizes which can accommodate that. And obviously with a commercial use you need bigger spans than you do with a residential system. Fundamentally it's a post and beam system with CLT or rib deck floors. And then this is what we've done, a whole analysis of the different component sizes that we need for the different range of grid sizes that we've got. And in this diagram you can see that we have integrated a services corridor so that each of these bays can be easily serviced by water, electricity, whatever ventilation systems need to be inputted. So this can vary in depth depending on uses. Looking at stability, we've considered a range of options for that depending on the scale and the height of the building. And fundamentally, the core and some internal structural walls provide sufficient stability for the building. And the core can either be in timber or concrete. We've looked at the detailing of the system, which is very important. I mean, building in timber is a really simple thing to do. It's basically getting these plates, these L-shaped plates that connect walls to floors, and then we've got some very nice connection details which sort of disappear, which you can connect the beams to the columns. What we've tried to do is make the floor construction as easy as possible. So you just lay that on top of the beams, but in certain circumstances where you might need an increase in floor to ceiling height in, for example, residential, then the beams can be cut out and the slabs sit on there. We've thought about the durability, and in our in the design guide that's going to evolve out of this, we will be highlighting key measures that you can take to ensure the durability of timber structures. So lifting the timber off the ground is one key part of it, and that can be done in several different ways, and it may depend a bit on the type of uses for the ground floor. Often you can have commercial on the ground floor and residential above, so having larger spans on the ground floor in a concrete structure might be suitable. And then also looking at roof structures, making sure that we don't lay an entirely flat roof. There needs to be a slight pitch so that water can drain away easily. Then onto the facade system, there were key factors that we needed to think about with that, and we worked with 𝗕𝗂𝗏𝗏 who are a modular fabricator in Denmark. We've done a lot of this work, similar work, and we've worked with them to devise a facade panel that can work for retrofit and new build. So some of the key aspects of this is that we want to make the choice of materials as efficient as possible. In this case, it's a timber frame facade panel. One of the key factors with facade panels is, especially off-site manufactured ones, is that they must be stable as they're transported. So the size of openings is key, almost more for the transportation than for the actual final install. And then we needed to make sure that it was very easy to install. So that means that we have the panels going above floor plates so that you can easily get a connector in between the top of the floor and the panel itself. Ease of assembly, trying to avoid the use of scaffolding if possible. If it could be, what we've tried to do is make it all possible to crane in. Production line, ease of production is really important, so it's a cheap and easy to fabricate solution. And then we've come up with this concept of the 3 layers. So we have a fundamental core to the facade panel, which you can then adapt to either to increase insulation, depending on what your regulatory requirements are in your area, and also can be adapted for acoustic requirements as well on the internal layer. So it's comprised of 3 layers which do different things to adapt to the different regulations across Europe. And then thinking about how the panels will be delivered to site. And one important factor about all this is that both the structural system and the facade panels are completely open source. So we have not been specific about a particular manufacturer that these can be sourced from. We're trying to encourage the broad use across Europe of different manufacturers and potentially encourage new ones into the market. And then this again just talks a little bit more in detail about how the facade panel is built up with these the 3-layer concept, with the external lining providing the rain screen, the breather membrane, and the insulation layer, which is the variable factor. The core is a timber frame with OSB board and vapor barrier for air tightness. And then the internal lining allows for acoustic variation, but also for services can be easily installed within the lining. So it's a very simple system and very easy to put together. And fundamentally, it can be used for any kind of building that the market may demand. So we've got residential, commercial, and also we've already done a prototype project for a retrofit extension to a project in Trondheim, where the same system was applied to add two extra floors of housing on an existing estate outside Trondheim. So this kit of parts which is completely demountable as well as being adaptable. It also has no wet trades in any of the details, which means that the demountability and end of life of the system is enshrined in the design. And it's, as I mentioned before, it's open source. So the goal is to enhance the way that we see timber in construction. Currently in life cycle analysis, the end of life is just about is about burning timber, and what we want to prove and show is that it's so easy to kind of take a timber building apart and reuse it in a different use if that's what's required, or you can reconfigure the building to change the use from residential to commercial. And so this gives you an overview of what the system guide will contain. It will have a description of the system, as we've talked about. It will show the components that the system will be made of. It will then talk about how that can be configured in lots of different ways. So ideally what we will be showing is that if you have a residential building of 6 stories, you can plug in what your requirements are for your building, residential or commercial, height, length, the footprint of the plot, and then we will be able to start to show how many elements would be required for that, and it will be able to size those elements for you. And then there will be a guide on the detailing and durability aspects of the system, so that any lessons learned from other projects that we know of are brought into every new iteration of the building. And I touched on this a little bit earlier. What we've tried to do is to make it as simple as possible. So overlaying floor plates on top of beams, rather than trying to use beams. So in this example here, the beam is less deep than it is wide, and that's not the most efficient use of material. So the way that we've designed the post and beam structure is to be as materially efficient as possible, because while we want to use timber, we want to use it in the most efficient way. And where we do need that extra bit of height, we have got a detail which shows the floor plate sitting on top of a beam. And this goes into a little bit more detail about how the slabs and the glulam post and beam structure integrate to ensure that the services can be integrated into the building effectively. So we have this service corridor running along here, and the services then go into each of the bays along the building. We decided against some of these other options because it was less materially efficient, or it was not so used, the way the services could be distributed was not as efficient. And then for our next steps, we're looking at prototyping and testing. So the system itself will be tested for fire, acoustic, and thermal performance. Some of these tests have already been done, some of the smaller ones, and then we're going to do some large-scale testing as well, which will happen at the Danish Technical Institute. And that will be for the bay itself with the facade panels on it, but also individual components are going to be tested on a case-by-case test. So we have this large-scale prototyping going on, as well as small-scale 1D tests. And then thinking about life cycle analysis, and which is a key factor in development of policy as well. We're finding in the UK that there's been an exponential increase in understanding what the embodied carbon implications are of different materials, because of needing to give a life cycle assessment when you're submitting planning applications. This is something that's going to evolve over the next few years, I think. Currently in London, there's a fact-finding mission where assessments, life cycle assessments are being done on buildings that are going into planning to get a sense of where people are at the moment, and then that will be overlaid with a series of targets that we should be achieving, which relate to working towards zero carbon. And so the more we can support the life cycle analysis of timber buildings, the more successful that will be. And currently the embodied carbon and the sequestered carbon rather within timber is not factored into this typical assessment that we use. And so we're lobbying heavily to try and get an overlay to this, which includes for sequestered carbon. And also in this analysis, as I mentioned before, timber is at the end of life is thought to be the only way to deal with it is either burning or composting. But what we're also working towards proving and identifying is the reuse of timber in construction. And finally, timber, as we said earlier on, is a renewable material. So in fact, the fact that it's already regenerating as soon as you start to use it. So it has a double benefit of also being reusable at the end of life, but also being renewable at the beginning of life. So it is a significant answer to our carbon emission issues that we have, and reducing our carbon footprint in construction. So I hope that gives you an overview of the system that we're looking at, which fundamentally is open source, can be used for different uses, residential, commercial, or retrofit, and we're working with our partners to kind of allay any of those concerns, such as fire and moisture and acoustics, and make sure that there are key tests that are done that prove that the system is usable by everybody and can be used by everybody across Europe. Thank you very much. I'll now hand over to Peter.
Yeah, yes, me. Thank you, Kirsten. So, thank you. My name is Peter 𝗕𝗏. I'm Vice Director at Center of Wood and Biomaterials at Danish Technological Institute. And as Anders mentioned, I have this very catchy title, Why Timber is Better Than the Building Law Think It Is. And hopefully I can answer that with this next 15 minutes. We also saw this earlier on Anders' presentation, that we have identified some barriers for market uptake in the wood construction sector, and I have tried to bold some points out here that we are kind of addressing with the work we have done on the regulatory barriers. This thing about legal legislation and on the and non-harmonized legislation, these type of input, safety and performances concerns. So these things we have looked into a bit further in this work package 3, where we have done this analysis. So yeah, actually the question is here again, why is timber better than building law think it is? And I think the answers to this is, of course, we have had some historical fires in cities that kind of had set the focus on the building law development around not only Europe but around the whole world. And there has been for many years, last 100 years, a focus on other building materials than wood. Yeah, but here we have actually the slide with the why we think that building law is better than timber is better than building law think it is. As mentioned, we have these historical fires that has set the rules for the regulation previously, and also that's the starting point for setting the new rules. There's been a focus on other building materials and a long experience with materials as concrete and steel, which has set the framework, you can say. Then we also have a very conservative building sector, which kind of it takes a long time to actually adjust inputs in, and we must also say that maybe the lobbyism from this part of the sector has not been strong enough to change these things. So our objective in the project here has been to identify the differences between member states' building regulation requirements for especially multi-story buildings. And we have also some inputs to give a recommendation on how to improve these areas, both on material component, but also building system and building level. We have made two focus areas, you can say. One is to create the regulatory overview, and another is to look a bit deeper into the design criteria. We have heard from Sabina earlier that we have these early adapter cities that we also have a focus on having inputs from them, and also hopefully be possible for us to give input to those cities as a starting point at least. So why are we having this approach? Well, today we do not have this overview. There's no single entry point to be found in Europe. We also need this work, as Kirsten just told us, for our building system development and the adaptability of that in Europe. And then we hope by doing this that we have created some kind of template that might be useful not only from the 𝗵𝗫𝗪 consortium, the partners, but also in the sector outside the 𝗵𝗫𝗪 consortium. And what makes this difficult then? First of all, talked a bit earlier about the tradition and experience. It's not a short term to change these things. Then another thing is that we have different needs for building performance around Europe, of course, different snow loads, different needs for heating, cooling, etc. And there's also different levels of support of the supporting tools, how our fire brigades set up and stuff like that. That kind of also have an influence on how to set the rules on national level when it comes to building regulation. When it comes to national annexes that we are using in relation to Eurocodes in Europe, then there's no harmonized access to these national annexes. So therefore, we also have tried to deal with that in our work. And of course, then the lack of harmonization. We have different schemes and descriptors for, especially for acoustic performances of building, that makes this kind of harmonization a bit tricky. So looking a bit more into the work, we have tried to divide the work in how are these things set up in a more general basis. There's some literature done on that that kind of have made this issue very good overview on that part. We have tried to make this overview to find this national regulation. So we have created an Excel sheet where it should be possible to go in and find these different regulations nationally, and also the links to the relevant paragraphs, guidance, national annexes, standards, etc. Hereby we can also identify what are the differences in how the member state building regulations are formed. We have tried to link this work to the basic work requirements for construction works mentioned in the CPR, the Construction Product Regulation, and by this also have a kind of an interaction to the framework around how to declare performances on construction products. Yeah, I'm not go much into detail with all the features there, but there's different things that we can link to the paragraphs. We can also have direct links out to where to find the documentation, where to find the guidelines, some basic information about the specific member state regulation, and then again this filtering options on the different areas there. So this is the overview. Then going into the design criteria, there's of course a lot of areas that is important for designing a building. We have not covered them all by this approach here, but what we have tried to do is look at some of them, the fire, acoustic, and energy part, because they are some of the parts that are kind of being the tricky ones, and especially when we are comparing between member states requirements. So we have tried, as also Kirsten mentioned, tried to divide the work and kind of what is the requirement on residential part, what is the requirement on commercial part, but also what kind of range do we need to aim for to have an adaptable system here. On acoustic, we have, of course, the airborne sound insulation and also the impact sound level that we need to look into. And as mentioned before, there's many different descriptors that are used today in this area, and that makes it a bit difficult to know what to expect and what to aim for, especially when you have to give a system that could be fully adaptable throughout Europe. We have tried to make these sheets in a way that we are able to kind of filter by member states. We also are able to see the different descriptors, have the reference to the documents where we have found the information in. We also tried to kind of say, okay, one thing is to look at a member state and then trying to divide these levels of high, medium, low level into different member state requirements, but we can also normalize these values on normalize them to the EU population. So then that makes also sometimes the graphs the 𝗵𝗫 are a bit different. And the fire level, the reaction to fire, we have looked into, and we also have looked into the resistance to fire. Fire level is another way where there's of course the structural components focus, and also the reaction to fire, where it's more for the linings and the external walls that has this focus. Trying to group the buildings and having the filtered here, there are more lines into these Excel sheets, and here regulations are not described in the same way. What we have tried to do is to group them into different stories, you can say, a number of stories, and try to set the framework there in order for us to be better to compare the different requirements. Again, here we have tried to do it member state wise or population wise. Here we have some different levels, that is when we talk about resistance to fire, for instance. So what we actually would like to do further, because we have actually done some work already, that is their spreadsheet to be found at Zenodo, and there are quite many data in them already, but we actually like to have them improved and also validated in a better way with more specific data, and also have some inputs on how are these things to be useful also outside our 𝗵𝗫𝗫 consortium. So looking for collaboration, we will say, on this part to improve this and validate this, also to make this output useful, to have it to do timber for a timber industry to tackle these regulatory barriers that are throughout Europe, and maybe also have this work to point at which points we need to focus our legislation for national and European level. So very much like to have input on this part also from outside the consortium. I think that was actually all for me at this point. And I guess next one is 𝗕𝗿𝗿𝗀𝗃 and 𝗕𝗂𝗏.
Hello. Good morning to everyone. 𝗕𝗿𝗏, can you share the screen?
Hello, hello. Yes, of course, no problem. One moment, please. Okay. One moment. I don't, Sabina, I don't.
Oh,
okay, I see it. All right.
sorry for interrupting. I think according to the plan, it was the post-occupancy study first.
Okay.
I think we can go ahead with this presentation, and then we close with the post-occupancy study.
Right.
Okay.
Sorry for the delay. Well, my name is 𝗕𝗿𝗏𝗀𝗃. I'm technical director for 𝗕𝗵𝗽𝗁. We specialize in BIM, and we're leading work package for the Building Wood project. Together with my colleague 𝗕𝗂𝗏𝗄𝗏. I don't know if you want to present yourself, Nicoletta.
Yes, I'm 𝗕𝗂𝗏𝗄𝗏, and I'm here representing the University of Siena, and we are the leader of the work package 6 that is fully devoted to the sustainability assessment of the Building Wood project. We, in a very few words, our approach is based on the life cycle approach. So we are going to assess the whole sustainability, let's say, from the extraction of the raw materials until the end of life. And related to the project in general, we are dealing with the assessment of the forest carrying capacity up to the assessment from a life cycle point of view of the whole solutions that we are proposing as a consortium. Okay. And now today we are presenting a first attempt of our joint work, so the work of 𝗕𝗿𝗏𝗏 and 𝗕𝗵𝗽𝗁 together with first results obtained in the work package 6 related to the LCA of some construction elements.
Fantastic. Thank you, Nicoletta. Well, as you can see from our presentation, we are joining the data for life cycle assessment and BIM in order to make the practice much more efficient in developing projects with wood. First of all, I'm not sure if you're aware or are working already in BIM, but just to give you a very brief glimpse of what BIM is. BIM stands for Building Information Modeling, and it's a methodology for creating and managing information of a project through all of its phases, from design, construction, and maintenance. So it can fit any type of project that you might want to do, even refurbishing or demolition. And the key benefits that it has is that, first of all, it improves communication and work efficiency. This means that you can reduce times and improve productivity. Secondly, it lowers risks. Why? Because you have much more information. That in turn makes it better for you to make decisions easier, or at least make the correct decisions. And thirdly, it's a system that it's adaptable and rearrangeable, which means that there's no one way that it has to be done. All components can be rearranged. You can start implementing BIM at the middle of the project development stage, or even if it's built. So it works quite well across the whole construction industry. Just one thing, BIM is not just one software. BIM is a lot of softwares. BIM is more of a methodology that needs to be worked across many different platforms with many different actors, many different stakeholders, and across every different stages of the project. So in turn, as you can see here in the image, you have one project, and what BIM can do is, if you have this this project with all of its data, you can easily see the project as well as its graphical aspects, but also see the project in data within itself or also within the environment. So we have the ability to work not only graphically, but also through data, which makes it makes our practice much more powerful in construction. What we've done for the Building Wood project is, first of all, we started with the industry foundation classes, or IFC framework. I don't know if you're aware of this, but it's we're working with the IFC4, which is an ISO standard. And this is practically what gives us the whole range of data that we can use in order to input project specifications. From this, we've developed these 14 templates for building, zones, space, beams, columns, roofs, slabs, walls, etc., windows, doors, and materials. This allows us to map correctly the information that we want to include in the project. Just as a brief example, we can have an element such as a wall, and we have the groups of information as property sets, or P sets as they are known. Warranty, environmental impact indicators, condition, PZ common, etc. And within these, you see the range of information that we can add to our project, which means as whether or not it's external, if it's load bearing, what's the fire rating, if it's combustible, or does it compartmentate, or what's the status. The idea of having this whole framework implemented is that it can be used when it's needed. For example, it can be used by different types of professional disciplines, on different types of software, on different types of phases for a project, and depending on the level of implication that is needed, and also with the level of development that the project may be in. So it's quite flexible. How does this information work? Now, in terms of talking about the LCA information. Well, if we go to the left-hand side, we see a project that is made out of Legos, which I think is the best way to explain how we divide a project into elements or divide the whole project into information. Each individual piece, which we call an element, is divided into its proper categories. For example, it might be a roof, it might be a floor, wall, column, beam, or column. And with within each element, there are a set of materials that are associated to it. For example, if we take the wall, we might have the exterior finish, the structure, insulation, and the exterior finish, or the interior finish. And from the insulation, we have the LCA data included. For example, it could be just the area volume or even weight. We have the climate change potential, atmospheric acidification, stratospheric ozone depletion, and eutrophication.
Okay, concerning our first test, as I said at the beginning, so this is our first attempt to understand how can we have benefit of including LCA data within a BIM environment. We started by choosing a very easy element. So we choose together with the leader of the work package 2, that is 𝗤𝗍𝗀 architects that works together with work package 1, that deals with the material assessment. We choose some elements, the one that you can see in the list in this slide, because we would like to test our first bay. So we choose this element together, and we implement LCA assessment. Next one, please. What we did in terms of LCA calculations. So we decide to creating a database made of all the results in terms of product declaration, environmental product declarations. And since we would like to have general values in terms of at the European level, we decide to have an average value. So that means we are not referring to a specific producer for that element, but we are referring to an European values. This will enable us to have a very first attempt of the LCA evaluation, and we create these values concerning different functional unit based on the most representative one of the elements, and we set the system boundaries from the module A1 up to the module A3, since we are focused in this moment on the production process. And then we select some environmental impact, the one that you see before in the slide of Cristobal, so acidification potential, global warming, climate change potential, eutrophication, and stratospheric ozone depletion. We know that they are not all the possible environmental impacts, but we choose this for 4 just to have the first test and having results more variegated than only presenting the climate change potential. And for those elements for which we don't have an environmental product declaration available, we retrieve the environmental impact. So we calculate the environmental impact of those materials by using data from the 𝗂𝗍𝗋 database, that is an European level based database containing a lot of process already modeled inside, and we assess those impacts according to the CML-EA method, that is the one used also for the production of the environmental product declaration. I forget to mention that we decide to use data coming from environmental product declaration because those data are certified, as well as the data coming from 𝗂𝗍𝗋 are certified. So we can consider those data as solid and considered. When we have done once finalized our database, we extract the data and we pass to Cristobal for including those data in the 𝗖𝗍𝗄 framework, as he said before.
Okay, thank you. So our result for this is having the information in order for us to input into the software, which would be Autodesk Revit, which is the most used BIM software today at an international scale. We're able to produce this template that automatically calculates the LCA values for each of the 4 components, either at a total component level and at a building level. So you can see right now, this is a bay of what Kirsten in work package 2 from 𝗿𝗏𝗀 architects have mentioned to us. And we have this model, and we have the table of what it would look like. So we have the element name, the model, the unit, and the four LCA parameters and the source. So you can see we have the floors, the columns, and the structural framing already laid out. So, but I will change graphics here, and I will give you a rundown on how this can look. So we have here the software that is Revit, with the list of materials, as I showed you. If I were to eliminate these projects, you see that everything starts to go blank. There is nothing shown. But when we start adding in the data, which would be based on the components that we are using, if I add 1 component, I already get the calculations for, as I said, the total element level and as a whole project. So that means that if I add more elements to this, such as a wall, I can also draw a wall here. And now I get walls with all of the components already added up. So that means this can save us a lot of time and also provide information in order to reach the desired results or the benchmarks that we are looking for within a project. All of this while we are modeling or we are designing our project. So it's quite an efficient combination.
Yes, and I would just like add that by having this this calculation, we consider this as a very first check of the environmental consequences of the design choices. So when we will have finalized the BIM with all the elements included, we will let designers to choose different elements of different materials for the same purposes and see the consequences of in terms of the potential impact. Anyhow, we are well aware that results represent a very first and easy way for LCA as calculation of a project. The whole LCA will be should be implemented considering the whole life cycle. But this is a first double check that is, in our point of view, very important for designers and for let them know that there are also environmental impacts that should be taken into account while designing a solution or a building or whatever they would like to design.
Okay. And also I would like to add that this being a parametric software, it's still not limited to only one design. It can be adapted to any kind of design that you might be looking for. And depending on the design that you will have the representation accurately at the generic level with the LCA data. The idea is for this to give you a first glimpse into your project's performance in terms of sustainability, and then swap these elements out for manufacturer-specific components. And having said that, this will be the end of our presentation. I don't know if you have any questions.
At the end of the session, after the last presentation, we have a Q&A especially allotted for all the questions that we received in the meantime and everything that anybody wants to ask additionally.
Okay.
So thank you, Cristóbal, and thank you, Nicoletta. And now we move on to the final presentation of today's webinar. It's the post-occupancy evaluation of timber buildings.
Thank you. Here we go. So hello, everyone. My name is 𝗕𝗂𝗏𝗪. I'm with the Danish Technological Institute and the Center for Wood and Biomaterials. And together with my colleague Sophie Naylor from Alexandra Institute, we will be briefly introducing our work on the post-occupancy evaluation of multi-story wood buildings so far. Just to give a quick overview, we will talk about the objective of the task, as well as the two parallel assessment approaches, and finally, invite all of you to send us tips for occupied wood buildings that we could include in the project. So the objective of this task is to carry out post-occupancy evaluation of the existing multi-story wood buildings. And the approach includes both evaluation of the technical performance of the buildings, as well as perceptions of the building occupants. And the motivation behind this work is to achieve a better alignment between the design values and the actual performance in use, and then to document and share this knowledge. To assess the technical performance, our primary goal is to collect data that is already calculated or monitored during the earlier phases of the building project. Then to compare the estimated values with the realized performance of the building, and also to compare how these technical performance and the user experiences align. The main focus on the technical performance assessment is on the energy consumption, the acoustic performance, indoor climate, and indoor emissions. And for us to evaluate this, we are investigating the historical measured, and also surveyed data that we can acquire from these buildings. In some cases, it might be possible and relevant to also carry out on-site measurements to support this existing data. And my colleague Sophie will talk more about the assessment of user perceptions.
Okay, thank you, Henrika. So at the Alexandra Institute, we are responsible for the assessment of the user perception of living in these multi-story wooden buildings that we are discussing today. So throughout the project, we will conduct a number of case studies across the participating countries with the aim of holding the user perspective. So this is a question of what leads occupants to move into wooden buildings, and how important are the building materials in this choice and decision making. It's also investigating what experiences the occupants have when they live or work in these multi-story wooden buildings, and to which extent are these materials important in people's lives and in their perceived experience of living or working there. So we are focusing both on users as the occupants or the people who work there, but also the people who will work with the building. So the facility management, how is their job and the tasks that they perform impacted by the materials that they are, that the building they are working on and in is made of. And Henrika, you can go to the next slide. So the objectives of our task is to understand the role of the building materials and to understand how wood as a building material performs through experience. So as Henrika said, there's one part which is to identify whether the building performs as expected, and we are adding the perspective on whether these measurements are the ones that are relevant for the actual users, the actual final users. It's also to enrich the strategic branding of wood as a building material and to identify what is important, as I said. So if you go to the next slide, we have conducted one pilot study now in Denmark, together with the Technological Institute, where we've added these two perspectives from the technical and the user perspective, and we are ready to broaden our horizon and look at the rest of Europe and maybe some of you early adopter cities as well. So we would be very grateful if you have any candidates that you know of, any buildings or contacts that you think could be relevant to look into. Broadening it to a European perspective, of course, means that we will be able to look at what is particular for different countries, because there are a lot of variations in the in the skills and in the sort of cultural view and the history of building with wood. So we are very excited to broaden the perspective, and we have this QR code here and also a link that you are more than welcome to go to and leave your contact information so we can reach out and maybe include you and your stakeholders in the coming projects. Okay. Thank you.
Thank you all.
So thank you everyone for the presentations. I think that concludes our presentation session for today. And now we have some time left for the Q&A session. We received several questions via the Q&A answer module. Some of them I would like my colleagues to take the floor and address, and also something for the participants. If you have a question, you can either write it, or at this point you can raise your hand so we can offer you the possibility to pose the question live. So one of the first question is from Reinhard from the metropolitan region of Amsterdam. Why would above 10 stories not be possible? I think that was in connection to something from the intro. I think it's very much possible, but we focused on the lower hanging fruit. And I would like to pass the microphone to Anders or Peter to just quickly explain what we consider as wood building and why we chose that that height for the buildings.
So maybe I don't know. I can make an attempt of that. So the scope here, we limited that to that range between the lower range of the multi-story buildings, simply because we want to achieve the highest impact. So that's the reason why we chose that range to optimize a building system for that. I think actually the question of the possibilities here in terms of going beyond 10 stories on the building system is better answered by Kirsten, maybe if she's if you are there, Kirsten.
I'm here. Hello. Yeah, it's absolutely possible to go higher, and the system that we've designed could be higher. But at the outset, when we were starting to design it, there are so many variations to the regulations across Europe, and fire particularly is an important one to consider when we're thinking about height. And so when we started out, that was a limitation we sort of set so that the kind of extent of our research wasn't sort of exponential and endless. But there's absolute, we've built buildings that are taller than 10 stories in timber. So yeah, it's not an issue. It's just us constraining the limits on how far we went with it. And we did feel that, as Sabina said, we would hit the low-hanging fruit and go for a development scale that was going to be most applicable to most cities across Europe. In London in particular, I mean, there's a huge demand for tall buildings, so it is something we're looking at. Hope that answers that.
Thank you, Kirsten. While you're here, there's another question from Bob van der Zande. Is the maintenance in the long term of facades in wood more expensive by definition compared to traditional building materials?
I would say that if your detailing is correct, and that applies to any kind of method of construction, I think, then the longevity of the product is absolutely fine. I mean, we're not saying that the cladding is going to be in timber. That's not necessarily the case. You can apply, obviously planning rules change across different areas and different locations, and the reason for having this 3-layer system is that facade panel can be adaptable. And can change. So you can have clay tiles, you could have Eternit fibre cement cladding, you could have timber cladding, or metal cladding, zinc even. Yeah, there's lots of options for how that panel will be finished. Perhaps that was more the direction of the question rather than the actual build-up, because I think the build-up, as long as you ensure that it's watertight and the dew point is not within the structure itself, which it should never be, then that should last a very long time.
Thank you. A question maybe for Nicoletta. It's from the chat. Are you aware of any studies or initiatives which do look into the consequences of a rise in demand for wood, the sustainability of increased use of wood, and the consequences seem very ignored in most places? And I think this ties, just one second, this ties with another question of Bob van der Zande. How can politicians and policymakers be sure that used wood comes from sustainably managed forests?
Thank you. Yes, I try to reply to in a general way by combining all the both questions. We are well aware that we need to assess the overall sustainability of the products that we are proposing and we are testing as solutions, so that we are going to, and we are currently implementing the carrying capacity assessment of the European forest, so that we will be we can have a picture of our forest, and we can be sure that what we are proposing is sustained by the forest that we have, so that we are not proposing something that is not supported by the natural system that are sustaining the our life. So we are never proposing something related to destroying all the forest, and we are aware of the needed to assess and to consider sustainable managed forests for this. So in this sense, our assessment, so the life cycle assessment, is considering the whole from cradle, that in this case the cradle can be represented by the forest up to the end of life of the product that we are proposing.
Thank you, Nicoletta. What do we, so there was a question from Tando van der Zande, whether the emissions from material production are now higher than emissions from lifetime operations of new buildings. This is a very powerful statement. What can we tell him about this in terms of studies?
Yeah, so that statement is, it's obviously when you make a one-liner statement there about a complicated thing, it requires a little bit more explanation. So the long story here is we've had through, say, in Europe for the past 50 years, maybe beginning in the 70s, I guess, legislation beginning to target operational energy and cutting down, the cost of operational energy. And so we began to insulate our buildings and being more and more efficient about that. And if you make a graph showing the distribution between the contributions from emissions from production of materials and operational energy of a building from the 70s, the portion of emissions coming from the operational energy will be way higher than the emissions from material production. Now, what has happened is, as we've gone along and are now entering the 2020s, we've become so efficient at cutting down emissions from the operational energy that this portion for a lot of modern, you can say, construction is now actually lower than the emissions from the operational energy expected is lower than the contribution from the materials. And then that's not the case for all buildings, of course. It's always a case for the individual building, but in general, that's the tendency. And that's why it becomes very important now to kind of also focus on the contribution from materials, because we basically not had any focus on that from a legislation point of view, and still don't. And so while we picked all the low-hanging fruits from operational energy, we have a lot of low-hanging fruits actually hanging right in front of us in terms of materials, and one of these being, using more wood in construction. So I hope that answers a little bit the question, but there are certainly studies. So then you would have to find LCA studies for modern buildings, and there are a lot of those studies available. So we can help you with that. You're welcome to drop me an email, or you can see what we can do.
Thank you, Anders. Another question from Reinhard. How would you prove EU policymakers the end-of-life scenario of reuse or prolonged use instead of burning?
We are going to prove that prolonging the life cycle of the materials, or recycling or alternative scenarios for the end of life is better than burning the wood itself. We would say that there is a bias in the standards for the LCA implementation, and we are going to demonstrate by applying LCA and applying those scenarios that it is feasible, and it presents and gave results more meaningful than burning as at the final end of life of our wood build made in wood, or at least the very end could be the burning, but after the multiple uses, so prolonging their life, in this sense, their lifetime.
Okay. We were also asked on about the methodology in which we want to collect all the different policies that might support or hamper the uptake of timber in the built environment. What we did so far, because we have this possibility to work with different contexts in Europe, so this is why we work with the early adopter cities. In a first step, we analyzed their local and regional policy framework, and we tried to map out policies that either offer explicit support or implicit support, or are even disincentives to wood building. This was a higher level analysis conducted for these cities. As a finding, we can tell you that except for Trondheim, there was no explicit support for multi-story wood buildings. And in general, at European level, the landscape of explicit policies is quite scarce. This is why in the second step, because this is a part of the project that is well, it's something that we try to do additional in order to support the methodological transfer. We want to classify them in explicit or implicit policies, and what we try to do is to group them based on thematics. So, for example, we want to take a look at policies for zoning and land use, policies for building regulations, public procurement, fiscal and zero money policies, such as fast-tracking permits for buildings in wood, policies for municipal buildings, policies for waste and circularity, and so on. So we try to group them, and we try to find good examples, and this is why the opening up of the dialogue with other cities is also very relevant. This is going to be conducted in a second stage, where we try to set up a community for discussing all of these different tools. For now, it's a process of collection and classification, and we will be able to provide, let's say, a distilled look into the possible instruments that would fit contexts in cities across Europe and beyond. I hope this answers the question. And we have, I think in the meantime, we have another question from Thomas Federici. How do you address Europe's forestry industry changes from coniferous to hardwood forest products such as beech, glulam, CLT due to climate change to replace even more steel concrete constructions as we started in Switzerland? It's in the Q&A panel. It's quite a long question, but maybe Nicoletta or someone else wants to address this, because it's clear that we need to adapt to the climate change impact on forests. Is it something that we should look at, we should take into account?
Yes, of course. Our first goal, let's say, is to prove that building with wood is better from environmental and climate change point of view than build with the traditional construction products such as cement, steel, and so on. And we are now, for the moment, focused on the coniferous wood, because it's the most used for the construction products, but I guess that maybe Peter or Kirsten can add something related to the use of softwood with respect to the coniferous one.
I guess the key thing is that the softwood grows faster than hardwood, and therefore we have more output of timber if we use coniferous. And obviously, the great thing about 𝗬𝗨𝗪𝗁 engineered timbers is that they are stronger than their individual components. So you can use from one log, you can actually use quite low grade parts of the timber. Obviously, the heart of the timber is the strongest element, but we're even doing research into using new timber on the outside lamellas of a CLT panel and recycled timber in the central lamellas of the panel. So going back to the point about LCAs, it's not necessarily just decommissioning a building and rebuilding a new building. It's how we can use the components, the timber within a building in new products. And I think that is a really interesting aspect of making sure that we extend the life of timber and reduce the use as well of new timber coming through.
Yeah, and I can maybe add to that of course we are looking into resource efficiency also and that part, but it is a large project with a lot of activities, and but we also have limited resources in looking into all details. So I would say we are it's not a research project; it's an innovation action. So we are trying to improve the current status. So one of the things is also looking at the current products available out there and what can they give us in order to build more timber buildings.
Okay. Last but not least, we have another question from Manuel Lobo. It's an answered question about a regulatory overview, and we provided everyone with the link to the Zenodo, but his question was, how can he collaborate to introduce the Spanish regulations on them? And how can anyone contribute on the Zenodo platform to provide their own updated data for other countries?
Yeah, actually, I don't think that they can directly access the Excel sheets. They can download them, but they are not able to upload some new ones. So they need to get in contact with us and have our interactions done that on bilateral ways. We will create a community. We will come back to that in a later. But that maybe that could be a platform where I also exchange views on these things. For now, I think it's via emails and exchange there. So please, welcome to send anything to me, and then we'll take it from there. But hopefully we have a platform also later on that is kind of more interactive, also in this area.
Okay. I think we answered all the questions in the module. So if anybody has any other aspects or questions or comments, we would gladly receive them right now. Or you can contact us at any time via the website and via the LinkedIn of the project, and also the Facebook if you if we prefer to use Facebook. If there are no more questions, then I propose to close this first webinar. And we would like to thank all of the participants for participating and for all the questions and for the attention that we were very pleasantly surprised that has been provided to the project and this webinar. I'm sure it's possibly the beginning of a beautiful friendship. And also thank you for all the panelists who presented what we are working on right now in Built in Wood and what we're quite proud to have achieved so far. The project is still a long way from closing, and there's a lot of very ambitious plans and very ambitious outputs coming up. So be sure to keep in touch with us. And thank you very much for being here. And we hope you have a great afternoon. And looking forward to the next session that we have with the cities. So thanks and keep in touch.
Thank you.
Bye-bye.
Thank you. Bye.